What is a pattern? Something that is repeated in different places. So for example, you have total fertility rate from 0 to 1, from 1 to 2, from 7 to 8, depending on the amount of kids or how fertile is a woman to have a kid, right? So tell me a pattern that you can see in here. Just one paragraph explaining which are the countries that follow or continents that follow the same patterns. For example, we have this one, this one, this one, and why? Just using name examples. Remember, when I say name examples, you have to name the countries or the continents in the map. Then we have another term, doubling time, DT. Doubling time is the number of years it would take for a population to double in size as at its current growth rate. So how? World population doubling time. Let's check this picture, okay? So, world population doubling time change is the number of years to increase the population to double. Let's see. In 1800s, we have the first billion, okay? All of human history. So the first billion, and then the second billion. So we have double this amount from 1 to 2 in 130 years, from 1880s to 1930s. Now, let's check what is happening here. To double, no, the third billion was reached in 1960, the 4 billion was reached in 1975, and the 5th billion was reached in 1987, the 6th billion was reached in 1999. So as you can see, it's to double the time. So let's check. First doubling time, 1 to 2 billion. How many years? 130 years. Second doubling time, to 2 billion to 4 billion. So let's check how many years. 1930 to 1975 is about 45 years. So you have to write 45 years here. Third doubling time to 2.5, around here, to 5. So around here is 19, from 30 to 60, 40, let's say 45, 1945 to 1987 is around 42 years, something like that. Fourth doubling time to 3 to 6 billion is around 1960 to 1990. 1999 is 39 years. So what can you tell me about that? The beginning was 130, now it's 39 years. The population is increasing rapidly, exponentially. So something is happening. We have to do something about this planet at the pound. Do you remember about the term carrying capacity? Is the maximum number of organisms of the same species that an ecosystem can support. As humans, we have our home, that is our planet, and we are exceeding that carrying capacity. What is happening to doubling time? It's decreasing, right? The number of years are decreasing. So it's very important to know that. Now we're going to talk about natural increase rate. What is natural increase rate? It's the difference between CBR and CDR. Accounts for how quickly population growth. Why? Because we're taking into account the number of people that is being born, less the people that is dying or is dead. So what do we have in this picture? We have the continents, different countries that we have in this planet. Natural increase rate, again, we're seeing we have the same pattern. Africa has countries that has the highest fertility, the highest number of births, so the natural increase rate is the highest. Then we have countries that has less NIR, natural increase rate, like countries like Europe, in which they don't want to have more kids, so more elderly people is living there. Ecuador has this yellowish pattern, so 1.5 to 1.9 is in the middle. We're having like from 3 to 2 kids. We're increasing the population, but not as much as Africa or as less as United States or other countries. So the first skill that we need to know is how to calculate values of CBR, CDR, TFR, DT, and NIR. Okay, this is demographic transition.